Dear students, welcome to my classroom. In previous class, we discussed about curved surface areas of combinations of solids and also solved two problems in exercise 10.2. And in this class, we are going to solve remaining problems in that exercise. So take the third problem. A medicine capsule is in the shape of a cylinder with two hemispheres stuck to each of its ends. The length of the capsule is 14 mm and the width is 5 mm. Find its surface area. Okay, students. Here the picture also given. So it is given that a medicinal capsule is in the shape of a cylinder to which both the ends attached with two hemispheres. And the length of the capsule is 14 mm. That is, this 14 mm includes both the length of the cylinder as well as diameter of the first hemisphere, and the diameter of the radius of the first hemisphere and the radius of the second hemisphere. Okay, so let us solve the problem. So here the shape of capsule is in this form. So this is the cylindrical part, and these two are at the ends of the cylinder. We can see hemispheres attached to the ends, and it is given in this in the problem. It is given that the length of the capsule is 14 mm like this. So this 14 millimeters includes length of the cylinder as well as radii of both the hemispheres, and the width of the capsule is 5 millimeter, and this 5 millimeter is the diameter of hemisphere as well as the diameter of cylinder. Okay, so it's given that the length of the capsule is 14 millimeters and the width is 5 millimeters. And from this we can write radius of the cylinder is half of the diameter, that is 5 by 2, which is equal to 2.5 millimeter, because here width is the diameter, that is twice the radius. And now uh, height of the cylinder, that is height of only cylinder, is equal to total length of capsule minus radius of the first hemisphere minus radius of the second hemisphere. That is length of the capsule minus twice the radius of hemisphere. So here we have length of capsule is 14 millimeter and radius of hemisphere is 5 by 2. So here the height of cylinder is 14, length of capsule 14 minus twice the radius, that is 2 into 2.5. And from this we can write 14 minus 2 into 2.5 is 5, which is equal to 9. So the height of the cylinder is 9 millimeter. Okay, now the surface area of capsule. So in this capsule we should able to see the curved surface area of cylinder and the curved surface areas of both the hemispheres. Okay, so the surface area of given capsule is sum of the curved surface area of cylinder plus curved surface area of first hemisphere plus curved surface area of second hemisphere. So we can write it as curved surface area of cylinder plus 2 into curved surface area of hemisphere. So that is, we have curved surface area of cylinder is 2 pi r h and curved surface area of hemisphere is 2 pi r square. So write the formula 2 pi r h plus 2 into 2 pi r square. So in this we can take 2 pi r common. So that is, we can write 2 pi r into h plus 2r. Now substitute the values of r and h in this equation. So we have pi is equal to 3.14, h r is equal to 2.5, h is equal to height of the cylinder 9 mm and 2r is 5. So after simplification, we get the value 219.8. So the surface area of the capsule, given capsule, is 219.8 square millimeters. Okay. So let us solve the fourth problem. Two cubes, each of volume 64 centimeter cube, are joined end to end together. Find the surface area of the resulting cuboid. Okay. So here we have two cubes like this, and volume of each cube is 24 centimeter cube. So volume of each cube is given, and it's given that these cubes are joined to end together. That is, one face of first cube is attached with the one face of second cube like this. Now the figure so formed is a cuboid, isn't it? So because in first one, the length, breadth, and height are same, but in resulting picture, the length changed to twice the side of first cube that we have taken, and breadth and height will be remain same. So the resultant picture is a cuboid. Okay. So now, so to find the surface area of this cuboid, we have to know the values of measurements. That is, length of cuboid, base of cuboid, and height of cuboid. So, but these values are not given in the problem. So to find these measurements, first take the side of the each cube is A. Okay. So let the side of each cube be A centimeter. Then its volume is A cube. Now the volume A cube is equal to 64 because the volume of each cube is given at 64 centimeter cube. So A cube is 64. Now from this we can write A is equal to 64 whole to the power of 1 by 3. That is A equal to 4. That is, the length of side of each cube is 4 centimeter. Now consider this cuboid. The side of this cuboid, the side of first cube is 4 centimeter, and the side of second cube is 4 centimeter. So the length of cuboid so formed is 4 plus 4, that is 8 centimeters. Okay. And the breadth is same as the previous picture, that is 4 centimeters like this, and the height is also remains same. So height is also is equal to 4 centimeters. Now the surface area of this cuboid is 2 into LH plus BH plus LB. So by substituting the values of L, B, and H, we get 2 into 8 into 4 plus 4 into 4 plus 8 into 4, and after simplification we get 160 centimeter square. So the total surface area of the resulting cuboid is 160 centimeter square. Okay. So take the next one. A storage tank consists of a circular cylinder with a hemisphere stuck on either end. If the external diameter of the cylinder be 1.4 meter and its length be 8 meter, find the cost of painting it on the outside at rate of 20 rupees per square meter. Okay. So in this picture, in this problem, we have a picture like this. So this is the storage tank, which consists of a circular cylinder attached with hemispheres at both ends of the cylinder. And now it's given that the length of cylinder, if the external diameter of the cylinder be 1.4 meter and its length be 8 meter, is given. So length of cylinder is 8 centimeter, sorry, 8 meter, and width of the cylinder. And here the width of the cylinder is the diameter of the cylinder as well as the diameters of hemispheres. Okay. So now given that diameter of the cylinder is 1.4 meter and length of cylinder is 8 meters. Okay. Okay. The length of only cylindrical part is 8 meters. Now, from this we can write the radius of cylinder is half of its diameter, that is 1.4 by 2, which is equal to 0.7 meter. And now the length of cylinder is 8 meters and radius of cylinder is 0.7 meters. So now surface area of tank, the surface area of total tank. So in this tank, we should able to see the curved surface area of cylinder and the curved surface areas of hemispheres. So surface area of tank is equal to curved surface area of cylinder plus 2 into curved surface area of hemisphere. That is 2 pi r h plus 2 into 2 pi r square. So taking 2 pi r common, h plus 2r. So by substituting values, we get curved surface area is 41.36 meter square. So surface area of the tank is 41.36 square meters, and we have to paint the outside of this tank. That is, we have to paint to its total surface area. So, but the cost of painting is, the rate of painting is 20 rupees per square meter. So the cost of painting the total tank is 41.36 into 20, because we have the surface area of the tank is 41.36 meter square and the rate of painting per 1 meter square is 20 rupees. So that the cost of painting per 41.36 meter square is 41.36 into 20, which is equal to 827.20. That is, cost of painting the tank is 827 rupees 20 paise. So this is the solution of given problem. So let us take the next one. A sphere, a cylinder, and a cone have the same radius and same height. Find the ratio of their volumes. So in this problem, we have a sphere, a cylinder, and a cone. And it is given that the radius of these three pictures is same, as well as height is also same. The height of the sphere is nothing but its diameter. Okay. So let us find the volumes of each picture. So here no measurements are given. So we can take the radius of all these three figures be r. So let the radius of sphere be r, and from this we can write the volume of sphere is 4 by 3 pi r cube. And here it is the radius of sphere and it is the height of the sphere, that is the diameter of the sphere, which is equal to twice the radius, that is 2r. Now the volume of sphere is 4 by 3 pi r cube. Okay. Next consider the cylinder, and we know that the radius of cylinder is the radius of sphere, as we have taken it r. So radius of cylinder is r. So it is r. And now the height of the cylinder. Height of cylinder is equal to height of the sphere, that is diameter of the sphere, which is equal to 2r. So the height of cylinder is 2r. And now the volume of cylinder is pi r square h, that is pi, radius is same r, and the height of cylinder is 2r. So here h is equal to 2r. So from this we can write the volume of cylinder is 2 pi r cube. So volume of cylinder is 2 pi r cube. Now consider the cone. So here also radius of the cone is radius of sphere. We have taken radius of sphere as r. So radius of cone is also r. Now the height of cone. Height of cone is equal to diameter of sphere. So which is equal to 2r. Now the volume of cone is 1 by 3 pi r square h. Volume of cone is equal to 1 by 3 pi r square h. R is same r and h is twice the r. So now substituting r is equal to r and h is equal to 2r. So we get 1 by 3 into pi r square into h is equal to 2r. That is 2 by 3 pi r cube. So now we get the volumes of all these three pictures. Now the ratio of volumes of these three figures, that is sphere, cylinder and cone, is equal to 4 by 3 pi r cube is to 2 pi r cube is to 2 by 3 pi r cube. So pi r cube is common in all these terms. So we can divide all these terms by pi r cube and we get 4 by 3 is to 2 by 3. And after that, by dividing 2, we get 2 by 3 is to 1 by 3. And by multiplying with the 3, we get 2 is to 3 is to 1. So the volumes of sphere, cylinder and cone is ratio of volumes of sphere, cone and cylinder is 2 is to 3 is to 1. Okay. Next, take the seventh one. A hemisphere is cut out from one face of a cubical wooden block such that the diameter of the hemisphere is equal to the length of the cube. Determine the surface area of the remaining solid. So here the picture is like this. So it is a cubical wooden block and a hemisphere whose diameter is equal to side of cube is cut out from one face of this cube. And let the side of this cube be A. Then the diameter of hemisphere is also A. Now we have to find the surface area of this remaining solid after cutting hemisphere from one face of this cube. Okay, so let the length of the edge of each length of the edge of the cube be A units. Now total surface area of cube is 6A square. Okay, and diameter of hemisphere is equal to edge of cube. So that the diameter of hemisphere is equal to A. So the radius of hemisphere is A by 2. Now curved surface area of hemisphere is 2 pi r square. As we know, the curved surface area of hemisphere is 2 pi r square and r is equal to A by 2. So 2 pi into A by 2 whole square, that is 2 pi into A square by 4. So we can write it as pi A square by 2. Now the surface area of the remaining solid after cutting hemisphere from one face, the surface area of remaining solid. So in this figure, we should be able to see all 5 faces of the cube as same, but the face at which the hemisphere was cutted is seen like this. Okay, that is, this white part remains same and this gray color part carved out, and it looks like a hemisphere. So the curved surface area of this hemisphere is 2 pi r square. and the remaining surface area is equal to total surface area of cube minus area of circle having radius a by 2, because the diameter of the circle is a by 2. So the radius of circle is diameter of circle is a. So the radius is a by 2, and we can see the curved surface of hemisphere. So we have to add curved surface area of hemisphere. So total surface area of cube minus area of this circle whose radius is a by 2 plus curved surface area of hemisphere, which we can able to see. Okay. Now total surface area of cube is 6a square minus area of circle having radius a by 2 is pi r square, that is pi into a by 2 whole square, and curved surface area of hemisphere is, we got pi a square by 2. So from this we can write pi 6a square minus pi a square by 4 plus pi a square by 2. It is nothing but we are subtracting 1/4 of pi a square from half of pi a square. So we remains with 1/4 of pi a square. So this is equal to 6a square plus 1/4 of pi a square. And by taking a square common in this term, we get a square into 6 plus pi by 4. So the surface area of the remaining solid is a square into 6 plus pi by 4. Okay. So this is the solution of this problem. And take the last one in this exercise. A wooden article was made by scooping out a hemisphere from each end of a solid cylinder, as shown in the figure. If the length of the cylinder is 10 centimeter and its radius of the base is of 3.5 centimeter, find the total surface area of the article. So here the article is given in the figure, and in this figure, two hemispheres are scooped out from both the ends of cylinder, and length of the cylinder is given 10 centimeter and its radius is 3.5 centimeter. Okay. So length of knot tank is length of cylinder is 10 centimeter. So the radius of curved surface area of cylinder is 2 pi RH. So as we have R is equal to 3.5 and H is equal to 10, 2 into 22 by 7 into 3.5 into 10, which is equal to 220. So curved surface area of cylinder is 220. In this picture, we should able to see curved surface area of cylinder and the curved surface areas of both the hemispheres. Okay, so let's find the curved surface area of hemisphere. Radius of the hemisphere is given that 3.5 centimeter. So CSA of hemisphere is 2 pi r square, which is equal to 2 into 22 by 7 into 3.5 into 3.5 and is equal to 77. Now, the curved surface area of hemisphere is 77 centimeter square, and the total surface area of the article is equal to curved surface area of cylinder plus curved surface areas of both the hemispheres, that is 2 into CSA of hemisphere. So 220 plus 2 into 77, so which is equal to 220 plus 154 and is equal to 374. So the total surface area of the given article is 374 square centimeters. Okay, students, that's all for today. And in next class, we are going to introduce with the volumes of combination of solids. So don't miss the next class. So until then, see you. Bye.